Here we see the reaction of methanol with hydrobromic acid. When we consider the mechanistic arrows, we see that the methanol is acting as a Lewis base. That's to say, it's donating a pair of electrons in the form of a lone pair. When we look at hydrobromic acid, the consequence of the red arrow movement is that we break the bond between the hydrogen and the bromine, and a negative charge builds up on the bromine, whilst a positive charge builds up on the hydrogen. The positively charged hydrogen is a proton. And another way of thinking about a proton is as a vacant orbital that's characteristic of a Lewis acid. Hydrobromic acid in this form is a Lewis acid. The reaction forms an oxonium ion. That is another way of saying a positively charged oxygen. Here we have methyl, oxonium, bromide. Another example of a Lewis base Lewis acid reaction that forms oxonium ion would be the reaction of a carbonyl, in this case from the molecule acetone, reacting with sulphuric acid. The carbonyl's oxygen's lone pair is the electron pair that's being donated to the sulphuric acid's proton's vacant orbital, again producing an oxonium ion as a result. In our next example, we see the reaction of a hydroxide, being the source of the donated electron pair, reacting with the carboxylic acid, that is specifically acetic acid. We form the resulting carboxylate conjugate base and water conjugate acid as a result. Lastly, we have water reacting with anionic amide. Again, the conjugate pairs are produced with hydroxide as the conjugate base and ammonia as the conjugate acid. All four of these examples are both Lewis acid Lewis base, but also Bronsted Lowery acid and Bronsted Lowery base.